Well, it's Monday, and I don't know if I can even fit this radio on the bench because we're not really geared up for big sets. But sometimes we have to do base stations. I'd have to declutter it a bit. But it's like, can anybody guess what this is? It's got a screw there, a screw there, a screw there, and it's 2781. And it's got a red sticker and it's got DIN sockets. So, yeah, it's a Telecomm TC9000. There's two versions of this. One has a selective call socket, and it has a selective call switch and a selective call light. And then there's this version which doesn't. We do have them both somewhere. Same innards, just slightly different on the features. So you probably lose the noise blanket, which is pretty pointless on FM stuff. So PA on the meter, or are they lights that light up? Must be lights that light up. So on-off volume, RF gain, squelch, delta tune, channel selector, and then on the back, and this will be fun to connect up to the test gear. We have DIN sockets for the output, and the usual SO239. Mark's tested it, and it does not work. Now, I can't guarantee I can fix this, and I'm going to say that I can only probably fix half of these if they came in for service. What's inside it? Well, you'll find it's a Grandstand Gemini, which is also the Wagner and the Atron, and also the scratches back with screwdriver Grandstand base station. So these were quite expensive. I think there's something like £179. No doubt they were dumped in 1985 in some clearance sale for £9.99, but when they were at the proper price, shall we say, they were expensive sets. And Telecoms are now Nevada. I'm not quite sure why they changed the name. I don't think they've got a bad reputation or anything. I mean, it was Mike Devereaux Music, wasn't it? And that's the kind of communications sector became Telecoms of Portsmouth, and nowadays it's Nevada. Why? Well, I don't know. I'm sure he hasn't gone bust or anything like that. It seems a very successful kind of business. I don't know why he changed the name, but there you go. It's like there used to be the Marathon bar in the UK, chocolate bar, and did all this advertising for year upon year upon year to advertise Marathon, hazelnut in every bite, and then one day it became a Snicker bar. I never bought one since. What was that about? So that was the international name. Did it mean they didn't have to pack them specially for Britain? Oh, good grief. What do you reckon to that? I've taken the wrong lid off. Mind you, bound to have this one off. So, I totally forgot, because it's a very long time since I saw one of these. And you take the top lid off. It's a very unreliable chassis. And it's unreliable for the same reason another expensive set is unreliable, which is the Shogun. Another good set. And it has a double-sided printed circuit board, and whereas these days the tracks between the different layers are plated through, in other words, at the factory the two sides are linked where necessary. On this set, and on the Shogun, it relies on component leads being soldered by hand to both sides of the board, or certainly by hand on the component side of the board. And there are also tin plate links, and they fail. The trouble is, you'll see there's a huge IF and VCO can filled with wax, which would take a very long time to remove. And guess where all the dry joints tend to be? You've guessed it, under there. The synthesizer is an unusual device. It's a UPC 2812C, 2812C from NEC, Nippon Electric Company. That doesn't stand for National Exhibition Centre like a car phone salesman once told me when I was at Nottingham Radio in the 1990s. A lady rep came round from a company in Birmingham and she said to me, did we want to take on a dealership for car phones, which we didn't. And she said, it's even our own make. And I looked at the car phone she was offering. This is when they were fitted in cars with a boot pack. And he said NEC on it. I said, well, that's not your make, is it? It's Nippon Electric Company. No, it's National Executive Car Phones or whatever they were called. I said, I think you said that in all seriousness. I think you've been told to say that. I said, go back, and when you hand your car keys in, tell them it's a load of bull and it's Nippon Electric Company. Fancied, arranging your what your firm's called around what the product is that you're selling. I'm just trying to think of an example which would be current, and I can't at the moment. But TTI, they make all these CB radios. They're one of the current models. It could be Tango's Trashy Industries or something like that. And we have our own make. No, don't think it would be Tango Tone if we did. Right. Well, this came with its factory original mic, which looks like it needs to go through a dishwasher, with its factory original 5-pin DIN and the factory original power lead. Now this tells me the radio hasn't had much use, and that tells me that the radio doesn't work, and probably hasn't worked since the guarantee expired in 1982. So I don't think, this may just be a show and tell. I might be able to get it to work in PA mode. I think we'll connect it to our crocodile clips despite the long lead, because I want to use with two power supplies. We've got one which is a higher current one for when we're doing business radios, which often draw 7 amps. Then we've got a 2.5 amp one, which is digital and variable. Well, the other's variable, but it's got digital meters, so it's a bit easier to set. With a digital current meter, we can see if there's any malfunction pretty fast, and we can set the current limit on this one. So I'm switching the power supply on now, and the radio's sat there hissing. It's at 13.7 volts, and it's drawing 340 milliamps, which is a good sign. I ought to compare this. We'll just turn the volume down. I ought to compare this with something more normal. Oh, here's a Midland 2001 chassis. So still talking about the same era, but and if we started looking at some of these micro miniature ones, there's a bracket for one of those little micro miniature sets you get these days. It's about the size of that. It's not even that VCO can's wider than this. The good news is we have a circuit diagram for the Wagner base station, which at least means we've got the basic circuit. It's a complicated arrangement. I'm hoping that enough of it works for us to do something with, and I'm quite pleased that it's sat there hissing, and it says channel 31, but that's unbelievable, because you know how we use channel 31. It hasn't been put on there by us. Mark will have tested it, but he would have tested it either as it's come, whatever channel, or on channel 20. So we'll start by plugging in the test instrument. Even the audio I see there is pretty tonker, and you know, it's another NEC device. It looks like the whole thing's sponsored by NEC. Well, we'll plug in this microphone. It goes into the side. I mean, what car could you put this in today? You know, you'd need some real dashboard. I'll say that again. You'd actually need some dashboard real estate. Back in the days of dreadful British cars, the Austin Maxi, you could put a Yaesu base station in one of those. So I'm going to switch to picture-in-picture. We've got the instruments on, and I'm going to switch to the low power range. So if it does 4 watts, it will be full scale deflection plus. Well, blow me. And it's on frequency, which I'll show you in nearly on frequency. That is unbelievable. Oh, does it receive? I wonder why Mark's rejected it. There must be something. Now, we were doing CPT yesterday, so I'm going to have to reset the signal generator to the more sensible band. Okay, so we're now on the frequency. Let's turn up the RF gain. It's up. There is no receive. So it transmits. Oh, it doesn't anymore. It did. It's like that, is it? We actually have one of those, shall I say, I'm going to say this carefully, we actually have one of those vibrator items on the bench. We have them on each of the benches here, and it does help us find the dry joints. I went into our local £1 shop 7 miles away in the town of Grantham and bought 4 of them, put them on the counter, and the lady behind the counter says, "Do you want a bag?" No, not at all. I can walk out with 4 vibrators for bench use. Now it's transmitting. Now it's receiving. Okay, so we've got something which is a bit dodgy, and we'll probably look on the other side. So we can see now why Mark's rejected it. Might not have to disconnect that speaker. So I'm going to look for obvious dry joints. There we are. It's gone again. It's come back. Okay, well, I'll pause the video while I have a look for dry joints. You know, if we wouldn't want one of these coming in for repair, because to actually unsolder everything and resolder it is just so time consuming. I think Mr. Chippy spent something like 14 hours on a Shogun. We charged him a token 55 quid, you know, but you know, I don't want to see another one. It's pointless. But we wanted to do one to prove it could be done. But you actually have to unsolder everything, remove the solder, clean the component leads, and then resolder. And you've got to do it on the other side. You've got to suck all the wax out of that VCO cam. Anyway, we'll go off record, and I'll see what I can find. Right, so it's working at the moment. So what I've done is to take away the shield plate, which is just there, because it seemed to me that that's where the dry joints were, and I've gone through about a dozen you can see that the VCO obviously is affected by touch. So using a ceramic tool so that isn't affected, I feel confident that we've got rid of it. Well, for today anyway. So we'll see what happens when we turn it back the other way. The shield plate will go on after this is complete, and it's still transmitting. So it's obviously one of the VCO things. So these are quite complex to set up, but this hasn't been messed with. It just doesn't work, or didn't work. There's an example of one of the plated through. Just zoom in on that so you can see it. Just to the right of the relay, we've got one of the connections between the tracks, another one there, and again these can be one there. They're all over the place, but predominantly they're under that can, and that's filled with wax, and that's where the big problem is. Take that wax out. So we'll start with a tune-up. Now I'm not going to have to go through, I'm hoping I'm not going to have to go through the VCO line because the multi-crystal mixer thing. So what I'm going to do, I'm going to dig out the service notes I've got for the base station, and we'll see whether we can actually get a bit more out of this. At the moment it's doing 2.6 watts. So the big problem is, where are the test points? I found the notes for the chassis. So you've got the reference is 10.245, not 10.24. Then you've got the 10.695 oscillator, and then you've got the 36.6162. So, you know, where can we test, because it's of the way it is. So it isn't easy. So let's see how on frequency it is, because it would be nice not to have to mess with that end of it. It means sitting down with the circuit diagram and working test points out, and you know, is it worth it? Camera 2. Well, it's well within spec, and according to my notes, we should be able to adjust what? Can't possibly be that one. It is. So there we have 2779125 by adjusting that coil just there, and that shouldn't have affected receive. We'll check that with the marker oscillator, because the receive one will be there, assuming that the 10.245 is right. I don't think it's going to be off frequency, because it just doesn't work. It's not like it's been messed with, because you wouldn't dare mess. Nobody would. A screwdriver expert would never surely mess with one of these. So let's go through the transmit. So our first transmit I've got. See, oh yeah. Transmit 1. No, it's 11 and 7. Transmit 1, transmit 2. Right, I'll move the camera back. Right, we'll start with that one, which should be the first of the transmit chain. No, that's affecting frequency 2. So forget that. Is that the first of the transmit chain? That is. So we're now at 2.6 watts, which is where we started, but the set's got warmer. 2.6. Let's go over to our trusty green hexagonal tool, or is it a different colour one for this set? Whoa, 2.8 watts. Aren't we doing well? That's actually the noise blanker, I understand. I will just twiddle it to prove that it's not on transmit chain. No, it's not. I mean, that looks like it ought to be on transmit. But no, I've just upset receive, haven't I? So we've managed to coax about 3 watts out of it. Yeah, so we're looking at a good 3 watts. If I stay in the 3 watt range, it's well exceeding that, and it's changed scale. It reads about 3.2, so about like a new set, but it will be a bit more when it's cold. So what about deviation? So we now know it's on frequency, and we now know that it's transmitting as well as it's going to. So we'll set this to there. We've got wallow. Actually, it's about right. But deviation, just for the record, is the preset just there. So I'll just do it with the wallow test. Wallow. You can get it to peak at 2.5. So that's spot on. So our S meter and RF meter is the preset there. Your sensor is in the screen box for the transmitter final. And let's see what it's reading. It doesn't matter what the radio is doing, it needs to be the centre of the red zone. It's nearly the centre of the red zone. So we'll just pop that up a bit. Centre of the red zone, we're done. So we'll move over to receive, and it obviously is receiving. set delta tune to the centre. Wish it had an off position. If I struggle tuning the receiver, we'll get the we're going to get the micro oscillator out anyway. But in fact, I will. I'll do that now. See if we can get a reading. So we'll turn the signal generator to no tone. We'll switch this on, and hopefully just when the signal generator decides to make a noise, try and locate the 455 section if it isn't in a can. Actually, deviation is in the can, it's down there. I don't know why I'm telling you it's up there. Don't know what that is up there. Is it low power? I'll have to check back on that. Deviation is definitely the one down here in the can. No, I can't, because of the screening can, I can't get the micro oscillator to be heard by the radio. So we may well have to do it for best synad. I like an instrument result, you know, I like something on a meter, on a display that tells me things are spot on, but with being a weird set. Yeah, definitely deviation is the one in the can there. So let's just see what it's doing on low power, because we're going to need a squelch preset. We're going to need, which is, according to my notes, is that one. We're going to need a S-meter preset, which according to my notes is that one. So, is that low power? Let's find out. I'll go back to transmit. We'll go to the 3 watt scale. It's banging across on that. Switch it to low power. It's doing 400 milliwatts. Let's just see what happens when we adjust that. Well, it isn't that. It actually says mod, but then deviation is down there. So what's that? Is it mic gain? Wallow. Let's just see. Wallow. So we know that's deviation. Wallow. We'll better set that again with the meter, with the oscillator. Seems to be mic gain, yeah. Wallow. It's too low now. Wallow. Testing 1 2. 1 2 1 2. Wallow. Turn that back to where it was. It's too sensitive. Wallow. Just listen to the effect on a monitor receiver. Testing 1 2. Testing 1 2. 1 2 1 2. 1 2 1 2. 1 2 1 2. 1 2 1 2 1. Wallow. 1 2 1 2. 1 2. I might be totally lying. Anyway, it's set back right. So back to receive. So we'll put the signal back on, and then we need to connect this to our SINAD meter. And this isn't as easy as it normally is because I haven't got any leads made up which are DIN speaker to the more usual 3.5mm. So it's possible that we only need to do the centre because the earth is coming from the rest of the system. Yeah. So that wasn't as hard as it could have been. So switch on the SINAD meter, switch on the oscilloscope, and let's see if we can do the detector. So we'll put an S9 signal on there, which is 100 microvolts for a CB in the UK. Just the volume, so I've got a reasonable sine wave. And the detector is going to be that one there. Have I got my notes? Have they run away? Yes. Wow. That was an improvement. If we change the delta tune, you can see it not being as good as it goes off frequency. Right, 0.3 of a microvolt, so jolly good sensitivity. These are very selective radios, so if you've got anybody who's over-deviating, whereas they might sound wonderful on the Fidelity 1000, they'll sound very chopped on one of these. So RX1 I think we're talking about there. Put that to move the camera onto the SINAD meter. I previously upset that coil, but I put it back right. I'm not going to disturb that. That's 10.245. That says receive on my notes. That's 0.15 of a microvolt. So that seems to be about where we're going to be with it. It's nothing to write home about. Right, the transmitters, and turn the volume down. By adjusting the delta tune, which is in the centre position, if I turn it to the right, you'll see the cyanide gets worse. If I turn it to the left, the cyanide gets worse. And if I have that in the middle, the cyanide is about at its best. So that tells me the radio is on frequency. But I would like to have seen it on instruments. So we wouldn't do one of these for a customer. It's on the definitely not list. So, Telecoms TC9000. So we'll do, if it'll do it, 20 dB cyanide, 12 dB cyanide, and 10 dB cyanide. So let's see what we can get. Whoops, wrong meter as ever. Meter, what am I on about? Wrong camera. So 20 will do it, and it's 1.7. 12. Naught 0.52 and 10. It's on that verge of 0.31. It's just between scales. So we've seen better, but we've seen worse. Don't think we need that on anymore. We need that on anymore. So what shall we look at? The S meter. So we'll put an S9 signal on the radio. It's just reading over the 9, so we'll just bring that in with the trimmer. According to my notes, it's that one there. Wow, that's a fine adjustment. And we'll go for the squelch. I think we'll start by seeing, we'll put it on 100, keep it on 100 microfarads to see whether we can squelch that out or not. And the answer is we can. We don't want to be able to. So, see whether we can adjust that. So it's just in. That's where I want the squelch to be. 100 microvolts is bringing it in just on max. So now we'll turn the signal generator off, turn the squelch to minimum, and set threshold. Bring the signal generator back on. Not very sensitive. 3 microvolts to open, 2.5 to close. I'll try and set the squelch a bit more fine. That's really on the edge. Signal generator back on. This time it's coming in at, it's still coming in at 3, leaving us at 2.4. So it's not a very user-friendly squelch. I wonder if we have it less coarse at the top end. So I'll just reset it. Just wonder if we can gain something at the bottom end, because it's not really very good. So I'll put the max to 30 microvolts. I mean, I turned the sensitivity, improved the sensitivity by my first adjustment. So let's just see what happens now. So I've switched the signal generator off, let's set threshold again. Switch the signal generator on. Yes, it's come in. The trouble is, it stayed in, so I'll have to readjust the squelch. It was 2 on the edge. Let's try again. Signal generator on, that was a false test. Well, it's hardly an improvement. It's coming in at like 2.99. We've hardly gained anything. And going out at 2.4. So, a bit of a dreary squelch there. But again, we've seen worse. So that is all I can think of to do. It hasn't played up. I'm going to leave it on. And we'll plug an aerial in. And see what people sound like. Well, Nana Roger. Helped her on high power. Well, Nana Roger. So we'll do an on the air test later and we'll see how this performs. And in the meantime, I might put that mic head through the dishwasher. Thank you for watching.